In this video, we're going to use sum and difference identities to help verify an identity. So we did verification of identities in a previous video. And remember, the concept is that the left-hand expression and the right-hand expression, if we have an identity, are identical in value for all input values x that are in the domain of the expressions. Just like 3 plus 2 equals 5, 3 plus 2 and 5 are equivalent, even though they don't look the same. They're not identical in appearance, but their value is the same. So what we do when we're verifying an identity is we use already established identities and algebra to manipulate one side through a sequence of identities and substitutions so that it looks like the other side. And if we're able to do that, then we've verified the identity. And my tip the last time was to pick the side that looks the ugliest and manipulate that to look like the side that is simpler. So in this case, the left-hand side is the ugly side. So we just start by transcribing the ugly side. So the sine of x plus pi over 4 plus the sine of x minus pi over 4. And then we go equals, and we use existing identities to manipulate the left-hand side to try to get it to look like the right-hand side. So here I want to notice that I have a sum of two angles inside the sine function, so I can use the sum identity for the sine function to expand this. And what I'm going to hope is that it cancels with something coming out of here because the angles are the same, but I have a plus and a minus, so I'm thinking something's going to cancel. So I'm going to use my sum identity for the sine function, which says that the sine of the first angle times the cosine of the second angle, which is pi over 4, plus the cosine of the first angle, which is x, times the sine of the second angle, which is pi over 4. The sum identity for sine says that this statement here is equivalent to this statement here, so I can substitute this for this. And then I'm going to put my plus from right here. And then I'm going to use the difference identity for the sine function to expand this. So I'm going to get the sine of the first angle times the cosine of the second angle. And this has a minus, so this is going to be minus. And then it's going to be the cosine of the first angle times the sine of the second angle, which is pi over 4. And then when I look at this, I want to see two things. I want to see that I have plus cosine x sine pi over 4 minus cosine x pi over 4. So those will cancel, giving us a 0. So I'll get a 0 from those two, and then I have this sine x cosine pi over 4 plus sine x cosine pi over 4. I have that twice, so I'm going to get two of those. So I get 2 sines of x times the cosine of pi over 4. And then I want to recognize that pi over 4 is a special angle. So on the unit circle, pi over 4, or 45 degrees, is a quadrant 1 angle corresponding to the ordered pair on the unit circle, root 2 over 2, comma, root 2 over 2. And we know that the cosine is the x coordinate on the unit circle, so we can replace the cosine of pi over 4 with the square root of 2 over 2. And 2 divided by 2 is 1, so we get 1 times the sine of x, root 2 over 2, and multiplication in this case is commutative, so I can rewrite it as root 2 sine x, which is what we needed to show. So we have verified the original identity.